Hi, welcome back to this video wherein our topic is still in the coefficients, equations with homogeneous coefficients. So here's another differential equation, x minus 2y dx plus 2x plus y dy is equal to 0. And once again, if you've tried this to do the separation of variables, then you cannot, because this is not separable. We have the function of m as a function of x and y dx, and here n as a function of x and y dy is equal to 0. So let us solve this using the coefficients of a homogeneous. Hence, we need to let the substitution. So last time we used the substitution, that is w is equal to y all over x. But for this specific example, you can also try to use the opposite substitution, wherein we let w is equal to x all over y. Okay, so either of the two is applicable, but if you use this, then your x might gonna equal to wy, and your dx is equal to first times derivative of the second plus the second times derivative of the first as well. Okay, so all you need to do is to derive the necessary algebra of this substitution, and then its derivative, its equivalent derivative. Okay, so if we let this instead of this one, so let's try this one, wherein x is equal to wy, and then we will substitute it on our differential equation. So we have our x is wy minus 2y, then our dx is w dy plus y dw plus 2. Our x once again is wy plus y dy is equal to 0. And then according to our step after we applied the necessary substitution, our equation will now become separable. But in order for us to fully separate the variables w and y, we need to simplify it further. So we have here wy w. Okay, so we have here, let's factor out y. So we have w minus 2, and then this term, and for this one we have, let's also factor out y, to w plus 1 dy is equal to 0. Okay, then right after that we can also divide both sides by the common factor, which is y. So we can cancel that out, and we've left with this term. So now let's simplify it further. So we have w squared dy plus wy dw minus 2w dy minus 2y dw. What else? We have plus 2w dy plus dy is equal to 0. Now let's combine like terms. So we have this one. We have 2w dy negative, and we have positive 2w dy. So if you sum these two, it will result to 0. What else? Yan. Okay. So how can we further simplify this? Let's combine this dy. So we have w squared plus 1, this one, and then dy, as well as this dw plus wy minus 2y dw is equal to 0. Then further we have factoring out our y again, equal to 0. What else? So how can we separate these terms? So since we have dy here, in terms, you need to divide it by this and this one also. Since we have y here, so let's divide this by y. Yan. So let's try. We can cancel this out, leaving us with dy over y plus can cancel this out. So we have a w minus 2 all over w squared plus 1 dw is equal to 0. Okay, so at this moment we've already separated y's and w's. So the next step is to integrate both sides. Okay, so for this one we have ln of y, but for this one we have we can simplify this by having w all over w squared plus 1 w minus this part minus integral of 2 w squared plus 1. Okay, and let me copy this. So we have plus the integral of this is we have 2 the derivative of this is 2w dw, so we have 1/2 ln of w squared plus 1, and then minus the 2, and then the integral of this part is the arctangent w over 1 or w, then our plus c. Okay, or you can also use ln of c, but we need to bring back the value of our w, which is x over y. So we have x over y. So we have ln of y plus 1/2 ln of x over y plus 1 minus 2 arctangent of x over y is equal to c. And using the property of logarithm, so let's multiply this by 2 pala muna. So we have ln of y squared plus ln of x squared y squared plus 1 minus 4 arctangent x over y is equal to 2c or c. Then, using the property of logarithm, we have, since we have plus, so we have a multiplication. So we have y squared times the x squared over y squared plus 1 minus 4 arctangent of x over y is equal to c. And then let's simplify it further. We have terms like this. So let me move this negative 4 tan at the other side. So we have, let's see, then from here you can cancel out y squared. So we have ln of x squared plus y squared, then it's equal to 4 tangent x over y plus c. This can be now our solution.